Hi everyone, it's Ono here, and this is the Creative Machine Learning live stream. I'm gonna do today live 94. For those of you who are new, my name is Nono Martinez Alonso. I produce these videos and tutorials on creative machine learning, and also the Getting Simple podcast on creativity, technology, and culture. And specifically today, what we're gonna do is continue what we started doing yesterday. So we started taking a look on Live 93 TensorFlow Lite, how to load the TensorFlow Lite runtime, how to perform inference with pre-trained models, and also how to read models metadata, to read metadata like the list of classes that ship with some TensorFlow Lite models from TensorFlow Hub. So without further ado, I think that's what we're gonna do today, and we're gonna get started with coding. I will really appreciate if you let me know if you can see me okay, if you can hear me okay, and you leave some comments on the chat telling us where you're connecting from. Don't forget to like this video if you're enjoying the content and want to support the channel, and to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. All right, so let's get started. As I said, we're going to continue where we left it yesterday. So that means that we're going to open the same Google Colab notebook that we did yesterday. I'm going to paste a link on the chat and maybe add it to the video description in case you want to follow. So I'm gonna copy that link, and all right, so this is a notebook from Live 93. I'm gonna put it there, and I might just leave this one as it is and build on top of it. We might clean it, so save. I'm gonna go here and click on save a copy in Drive. We're going to create a separate notebook just because that way we can leave the one that we did yesterday during Live 93 for those who want to follow Live 93 and not get conflicted with things that have changed after the fact. I just changed one little thing that I have to kind of mention here that is important because that wasn't there when we finished yesterday. And that, all right, so line 94, this notebook builds on top of what we did during Live 93. In this notebook. All right, and I'll make sure that I share this notebook as well because by default that's not shared. And I'm gonna put that on the live stream channel on Discord. If you're not on Discord, you can go and join at nono.mas/Discord. You'll find an invite. You can join this Discord server, and that way you can get access to everything that we put here. Call a notebook, and this is gonna go here. All right, so there you go. You have the links. We have this public, and I'm gonna put a link here as well. So notebook for this live stream, Live 94. All right, so the two links are now on the chat, and you can access them. Okay, let me see if everything's good. Yeah, everything's good. Okay, so the thing I wanted to mention, there is one thing that I've changed from Live 93 to Live 94. I said I was gonna take a look at that offline, and so I did. The thing that I've changed specifically is something that was making the classifications not work properly. Is this line here. So what this line is doing is that is remapping values from 0 to 255 the RGB values to 0 to 1, right? In the D type, we specify is float here, but you can see if we actually print here, we can make a test to see what this is doing. To execute this, though, I'm gonna have to connect to a runtime. So I'm gonna make sure that I have GPU here as always, and I'm gonna click here in connect. So we allocate a runtime, a GPU, and a CPU for our notebook. There are some things here that we're gonna have to execute. We don't really need to execute this cell, I believe. It's just importing TensorFlow and printing some things like the version and stuff to check that everything's working correctly. And we had two ways, as a really fast recap, we had two ways to load TensorFlow, the TensorFlow Lite interpreter. One is with TensorFlow, so import TensorFlow as TF and as tf.lite.interpreter. Here, note that we're loading the entire TensorFlow core. It's heavier. The runtime, for example, for 211 is around 500 megabytes, I think, the package that you have to install. And here, what we were doing is installing the TensorFlow Lite runtime package that installed just like a really small package compared to what we can see with TensorFlow. And you can see that this quickly makes the TensorFlow Lite runtime available to these notebooks runtime. All right, and the other way, as I mentioned, is that we can execute this cell of code. So we just load the interpreter from that TFLite runtime as TFLite, and then we print TFLite interpreter, and we get the interpreter. So this class, both this class and this class here, both should do the same for you in your code, but note that if you just want to execute and predict or run inferences with TensorFlow Lite, it's going to be easier. If you do it this way, because you're going to be able to do it, it's a lot lighter, has less dependencies, and can run even on edge devices like the Raspberry Pi, as we were taking a look at in Live 92, I think. All right, so inference with TensorFlow, I'm going to define these paths. I'm going to put this big here so you can see it. So we have the TensorFlow Lite model URL, which is a URL from TensorFlow Hub. You can read a bit more on the notebook. The path where we want to save that model when we download it from the internet. The image URL, which is going to be just some sample image that we get from the internet, and the image path, that is where that's going to be saved. Really quickly, let's actually look for another, like maybe, yeah, like a bird. Let's see if that is in our dataset, but let's just go a bit down so they're not like the first images on the internet. And okay, so let's grab, I don't know, let's grab this image. So with this image in mind, I'm going to just grab, oh, this is a PNG. Let's just look for a JPEG. With an image in mind, okay, so it's a robbing bird. So I'm just going to replace this here and put a JPEG, and we're going to execute this cell. So those paths are defined. Here we're going to download the model. So note how in runtime doesn't have any models here. And when this code gets executed to download the file, we get that model.tflite. We now load NumPy. This was one example to, in order, let me actually separate this import statement here. We load NumPy, and then here we were loading the TFLite model, allocating tensors. Here we were printing some stuff so you could see the input and output details of the model that we're getting through this cell. I'm not executing this code because this was using some test random data that is not really an image. It was doing the inference, it was getting the output, and it was displaying the output there, right? So these predictions, we were actually not doing anything with the prediction that we were getting, because this is just something that doesn't really matter. It was more to see if it was working or not. So here we download that image that I found on the internet. So you're going to see that this sample JPEG is now available on the notebook as an image. And what we do, I repeat the process above to load the TFLite model and allocate tensors, get the input and output tensors. So here we load the model, we get the details, and here, right, like just to debug, I did save the image to visually inspect the loading and resizing went well, worked. Save image. The image was loaded and resized properly. All right, so we're gonna run this, and if I walk you through this, we are reading a file from disk with TensorFlow IO. That same image, right, we kind of manipulate throughout these lines of code. We decode that image with 3 channels as a JPEG. I'm pretty sure we don't need this here, but I'm just gonna leave it. We resize, specifying the input shape, height, and width, and anti-alias to true. And then we, this is the important bit that wasn't really working there yesterday. We divide by 255 to map the images. So remap image values from 0225 to 00 to 01, right? So if I just execute this cell, you can see that, all right, so there's something wrong there. Input shape is not defined, and that might be because we haven't executed one of the top cells. This one here, so input shape, so we're going to define the input shape. All right, so we execute that and we execute this again. All right, so this worked now, and we're gonna get this input image as a sample here. You can see it's a 224 by 224 image with 3 channels RGB. It's a small size of this one. It's also been stretched down to be a square image. So that means that it's working and we can see it. But just to show you what I changed from yesterday to today, if I print here, so I'm gonna print the MP min value of image and MP max value of image, and I'll do the same in here. So if we execute this code, you can see that before we remap, before we run this image and divide it by 255.0, we have values from 1 to 255, right? So those are pixels. They're gonna actually be, if we were to display that image, we would actually cast them to uint8, because those are actually integer values from 0 to 255. Whereas when we remap, we get values from 0 to 1. I mean, this is 1, 0, 0, 0, 0, 1. So we're going to ignore that it goes over 1. But yeah, so that seems like it works. And that was making the model misclassify images yesterday because we were not inputting images on the right format in terms of the pixels. Okay, so now here we turn the input image into a batch of 1. So you can actually inspect these things. You know, when I'm talking, you have to believe me, but you can do just simply get the image shape and the input batch shape. And what this is going to do, we're going to see, you know, the image is a tensor of 2 to 4 height and width, 3 channels, and we just batch that and we have a batch of 1. If you take a look at yesterday's live stream, we saw that this is this format where we get the N is for num, or, you know, like the batch size. Then we get height, and then we get width and channels, right? In this case, our values are, channels are 3, width is 224, as is height, and batch size is just 1. Okay, so yeah, with that, we're just gonna remove this cell and continue, because here we set the input tensor, right? Like we get the input index and put it here, and then we get the input batch as an input. We invoke, so this is actually doing the inference part of the model, and we grab the output tensor by its index, and then those are logits, and we apply softmax to the logics to obtain probabilities, right? I put these comments this way, but maybe we just put them in place so it's easier. Because this might make it a bit easier to read our code. And we're going to print here. If you look at the output data, you see that the numbers are not really probabilities. They go from minus whatever. I mean, let's actually take a look at that. So let's actually see the minimum of output data and the maximum of output data. And we actually see that is minus 2 something to 9. And if we see the predictions to which we've applied this softmax, we're going to see that they actually they should go from 0 to 1, right? So the lowest probability is almost 0 and the highest is 87. All right, so we can leave this as it was. So we're going to get just the array of predictions, and we can get here the prediction, like the highest, the argmax, and we could load. So if we actually continue here, so we just, okay, so up to here, we just know that the class that has been predicted is class 11. And we don't really know what class it is until we look at the list of classes, right? Like we look at the labels, the actual labels, which we can obtain from the TensorFlow Hub page, or just looking at the ImageNet 1000 labels, or some other place. But in this case, we actually saw yesterday. So let me look for yesterday's link. So yesterday I put some links on the very same notebook, and you're going to find that through the notebook there's some mentions to explanations and links. And I said that we were using this MobileNet v3 large model, and in this page we actually see that there are two versions of the model, one that is TFLite default and TFLite with metadata. We're using this one with metadata, which means that there is an associated file here that is called labels.txt and contains the labels for objects that the model can recognize. So we can actually load that through through some code that the TensorFlow support library allows us to do. So here I'm going to install the TFLite support library, and actually we're going to update or upgrade to TensorFlow 2.11. So one thing, for those of you who are connecting live, I would love to know where you're connecting from, how you found us, and ask for your support, like in this video if you're enjoying the content, and make sure to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Thanks a lot for being there. Thanks a lot for joining live. And if you're watching this offline, you can also write a comment later and let me know what you think. Okay, so this is installing. You can see TensorFlow was 588 megabytes so far. So the TensorFlow core library is actually pretty big compared to what we did with TensorFlow Lite. I believe it was 2.5 megs, but I'm not sure. I would have to double check. That's what the statement said. So just to say this, they tell you can visualize the metadata with Netron, or you can read the metadata from TensorFlow Lite model into a JSON format using the metadata displayer, right? So I believe I do have the model here still with metadata. So I'm going to simply double click the model here, and because I have Netron installed, I can see the, I can see the model here. So let's actually put this a bit bigger, and I believe I can zoom in here, right? Yes. So this is a big model, but if you click on the input, you're gonna be able to read this this metadata. It explains what the input is, what it expected, like you know, it tells you what range the input numbers have to be. For example, here we see that it goes from a minimum of 0.0 to 1.1. And also we see that we're getting a logits vector as an output, and we have 1001 classes respectively. The first one, it's actually just 1000 classes, but the first one is background, so index 0 is background. And yeah, if we, I mean, I guess if we go to the output, we just get the same, we just see the same thing. And what's good, we can see here what we mentioned before, batch, height, width, channels. And here we get just like a batch of, you know, 1001 probabilities or logits vector that we can actually convert into probabilities with the softmax filter. So we open our notebook again. So now we have TensorFlow Lite support, and we're gonna load the metadata library from there and OS for some. Actually, I don't think I ended up using OS, did I? Yeah, so maybe we just remove this from here. Hopefully that doesn't make it error. And the first thing we can do is that we can get the metadata for the model as JSON. So we get that saved here. And we can actually preview that on here. So we get the description, we could print different things, but more importantly, we can see that in the associated files, we actually have the labels.txt file, and we're going to run the code that we did yesterday to obtain that. So we have that. We're going to see what associated files we have is labels.txt here. Now we basically are going to define a path where we want to save that, because we can just run display get associated file buffer, decode that as a string, and save that to another file. So we have into a txt file here, and we're going to also get the labels as an object here, like a list in Python, and we'll see with the prediction index we got a brambling. So let's see, was that number 11? Okay, brambling. Is that brambling? All right, so it actually seems like it classified our image properly, which was here. It says singing Robin, but you know, to me it looks like really similar. Let's just get another image from the internet. So we're gonna look for just a car here, and okay, that's not what we wanted. JPEG image. All right, so let's actually just take this one. You know how much I like sunflowers. So we're gonna put this here. We're going to download that image. So you see that should be in sample now. Okay, maybe. Okay, yeah, so that we've defined the path, but we need to re-download the image here. And now we will be able to see that has been replaced. It's taking some time to load, but it has been replaced. Okay, so we can actually just keep going. We can simply re-execute this step here, and then in the input image that is going to be smaller, we can see that flower, and we batch that and we predict again. So we just need to grab the prediction index again, and now we have 986. We're just gonna come here and rerun this thing here. All right, it tells us it's a daisy, but here it says it's a sunflower. Discrepancies, I mean, it's a really compressed model, but it works. And we have this last block here where we're going to print the top K classes, and it tells us Daisy, B, Weevil, blah, blah, blah. The one thing to note here is that if we go here to this list of classes, we might find that Sunflower is indeed not in the list. So if I do Daisy, it's probably the most similar to this image. So one thing that we could do is try a different model from TensorFlow Hub. So we could go to TensorFlow Hub again, so TensorFlow org hub, and go to look for the models now. And I'm gonna look for object detection classification, and I want TFLite only, and TensorFlow 2. So we're gonna use modern models. So you can see small edge TPU 100. Let's do here data set. Let's call ImageNet. I think this is the same one that we used, right? Yeah, so not sure if there are larger models. Large. Let's see which is the one that we used yesterday. Large. Yeah, this exact one. So I'm not sure if there are other models, but yeah, I mean, so this is the important thing, is that this is working, and I guess now we have the code, and with this code that we have here, I guess that what I wanted to do here is get get model classes from its metadata. Yeah, so this is what we're doing here, and then we can print the top K classes, and we have already that labels image there, and we can print the probabilities here, which, this is just a number there. We could probably format this a bit better, but yeah. So with this, we kind of finalized the example. So this notebook is now working properly. We just changed it slightly, and what we're gonna do is maybe I'll upload this to the GitHub repo at some point, but I think now what we can do is let's move into the Raspberry Pi again and try just to port this code. So we try to run this in the Raspberry Pi and see how it is working. I'm gonna show you really quickly a video that I recorded last week, in which you're gonna see how the Raspberry Pi is with the setup, because we missed some steps from the last time that I showed the Raspberry Pi, right? So I have the Raspberry Pi in here with the Pi camera module, and from the last time I actually did some things, and I'll have to re-explain the steps that I followed in order to get to where we are, right? But the long story short is that now I have the Raspberry Pi working with TensorFlow Lite and Python and the camera. So we are able to now run all these things in there. So let me open, as I was saying, let me open quickly a video that I have here, and that way you're gonna see what I mean. Let me see where this is. Okay, so this is a quick recap on where we were with the Raspberry Pi and the MLKit for Love. What I try to do is build an image with Imager, right? With the Raspberry Pi Imager in an SD card that we could put on the device. We installed the dependency libraries. I was following the Adafruit tutorial, and everything works smoothly if I installed the Raspberry Pi OS, the legacy version that's called Debian Buster, not Debian Bullseye. I didn't train a TFLite model. I just got a pre-trained model from TensorFlow Hub because I wanted to make sure that everything is working before we start training our models or getting models and converting them to TensorFlow Lite. And then we want to try to predict on device and display predictions from the camera, right, in the display that my Raspberry Pi with the MLKit for Lobe has, which is effectively a Braincraft hat on top of it with a fan and some of the things that I've already configured. This is Raspberry Pi Imager. You can see here I was writing the Raspberry Pi OS Lite legacy operating system to a SD card on my machine. I clicked on the settings option to pre-configure SSH access, the username and password, the time zone, and my Wi-Fi password and network name, so it could auto-connect to it and I could SSH directly to the Raspberry Pi as we saw on livestream 92. Then I ran into a lot of bugs, mainly because I tried to go with the latest of the latest. The tutorials were written in mid 2021 or even earlier, and I was trying to run the latest Debian Bullseye version, so it didn't quite work. So here I'm showing you a tiny video or tiny reel that I did. This is the Pi camera, and you can see how there is like a Pi TFT display that is working now. That's me with my hair before my latest haircut. And you can see that my Raspberry Pi is properly displaying that on top of the console. So with this setup that I have right now, we can move on to the next step, which is now that we have ported some TensorFlow Lite models, or we've obtained them from TensorFlow Hub, we can actually use those and try to predict and display a label live on the Raspberry Pi. That means that we're going to be classifying, getting a sense of how many frames we're running an inference per second, like frames per second, maybe 4, 5, 6, I don't know how many we're going to achieve with today's example. And we're going to use that model from TensorFlow Hub that classifies the ImageNet dataset classes, 1000 classes. All right, so let's stop this and let's take a look at the actual code. And we're gonna build on top of the code that we did on this tutorial. So I'm going to go ahead and plug my Raspberry Pi to the USB-C power. I'm gonna open my terminal, and here remember that I was just doing SSH Pi Raspberry Pi local, and that way we were able to access the Raspberry Pi. If I do this right now, it's not gonna work just because it's still getting started. It will take around 30 or 40 seconds until the Raspberry Pi actually switches on and gets internet access or network access at least to connect to my network. Okay, so it seems it already got access. So you can see if I let's see what happened here. it got hanged. So let's start from scratch again. So the device is on, so I just SSH and I get access. And now I can list that this is a Linux machine, and I can list the files that are on my home directory, which is a bit dirty, I'll say. So let's actually remove some of these things that have been, I'm not sure. I'm not gonna remove anything at the moment because I don't wanna break the setup that we have. We just know that this is working, and that it's going to be working for now. So let's actually just set it up, and maybe we can, so let's remove the model here, and let's see what we have on predict, what we had here. So note that we have some code here to interact with the camera. So it's not only going to be code to predict, but we also need some logic here to load the image from the camera and actually be able to get the image from the camera, convert it and into something like basically batch it for the model and predict. So here we have the TensorFlow Lite model. Let's actually leave out of the script the fact of downloading the model. So we do have code here. So this is our model URL. So let's do one thing. Let's just get this, and I'm gonna download the model. So let's download the model. We'll do here, do we have curl? Yes, so we'll do curl, put the URL, and then the output is gonna be home pi, that is my username here, model.tflite. And we're gonna download that, and that's downloaded. So we can see model.tflite. It's 21 megabytes, right? So I added this H flag to see this in like human readable. We can actually do this, right? Yeah, so 21 megabytes. Okay, so we have the model, and we have in our predict file, we actually have the path, the TFLite path here, and the model is actually okay. So we could actually do it this way or do it as we have it. So let's see how to load TensorFlow Lite runtime here. We could do it this way. So from TFLite runtime.interpreter import interpreter, but we could also do this. So import TFLite runtime interpreter as TFLite. And then here we'll change this to TFLite so TFLite.interpreter. And I personally, I think I like this one better, but yeah, so this is the model or the interpreter. And we're going to, all right, so in print, this is gonna fail, but let's just run it to see what's there so far right now. Okay, so we have invalid syntax. Might that be? Okay, so instead of editing this through Nano, I'm going to download that file to my, so that is actually a home pi predict.py. Well, we can actually edit the files from Visual Studio Code. So let's see how to edit the files directly from SSH from Visual Studio Code. I don't remember how to do this, but I've done it before. So remote development, the Visual Studio Code Remote SSH extension. Okay, so that might be an extension I don't have in this computer. So SSH, all right, 30 million. Great, all right, switch to pre-release version. Okay, let's see, SSH, add new SSH host. All right, so we're gonna do pi a. What is a flag? I don't know what a means, but let's just go with SSH pi Raspberry. Enter to confirm. Right, let me take a look quickly at my config here. So it's all right. So let's go for okay. So let me add a new SSH host. I'm gonna write here. So let's see how this is, right? So you see it also. I press Command Shift P on Mac. I put a caret and say remote SSH, add new SSH host, and I write the SSH pi at Raspberry Pi local. You could also have here another username, the IP address instead of the this name. And I'm gonna press enter, and I'm gonna choose my config SSH config file to which this configuration is gonna be added. And we're gonna connect. So I'm gonna connect there. And I'm not sure what's going on right now. So this should be Remote Explorer. So here, okay, connect to host, opening remote. Setting up SSH host Raspberry Pi local, installing VS Code. All right, so this probably is installing some stuff that the extension needs to be able to access the files properly to be edited on the Raspberry Pi. So this is sort of like how to edit the files that are on the Raspberry Pi remotely with Visual Studio Code without having to do everything on the terminal. All right, so that's doing the code server. For those of you who are connected online, I would really appreciate if you let me know in the chat where you're connecting from, what you're looking to learn here, or how you found us. And don't forget to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. All right, so let's keep going. It seems like we are here connected to the remote. If I write here, we have access. So we can open a folder. So let's open this folder. And yes, I trust the authors. So now I can see the files on the Raspberry Pi. So if I were to create a new file and say aquí sample, say here, sample, this is, no, and save, that's gonna be saved there, and I can do now cat sample.txt, and this is none. All right, so that is working indeed, and we're gonna actually remove that file. And this is really fast and really, really nice. Okay, so we have here now this file that we can actually execute on the Raspberry Pi. Let's see which Python version we have. All right, so we can do here clear and Python predict and click that, and we have a code invalid syntax. All right, yeah, so because, yeah, you see it's so much easier to see this here. All right, so we start that. This is actually starting my camera, and I'll explain later. But the important part you can see is that we're loading the model, allocating tensors, we load the model, and we see some things there. So we just need to understand this code a bit better before we do anything there. So allocate, so load TFLite model and allocate tensors. And these things, TFLite model path, let's just try to be coherent with what we have on the notebook. And now, so now I'm going to go back to the Python file, so the predict.py file, and we're going to add the code that we created here in the notebook, and actually make sure that we can do everything that we were doing in here in our notebook. So I'm going to simply paste these things because we have good comments. We don't really need to print the input and output details. So we already loaded the model. And when this script, so if we block this, the thing of this script is we're going to remove this code. We're going to load a few utilities time to measure how many frames per second we're inferencing the Pi camera to be able to display things like the feed, the camera feed on the display. IO, we'll see for what, and image peel is to be able to grab those images and resize them and pass them to the TensorFlow model and the TensorFlow Lite runtime. We define where our TFLite model path is. In this case, we don't need a sample image because the image is going to be fed from the camera, and we load the model, we allocate the tensors, we get the input and output things. And when this script runs, if the name is main, basically if you're executing this script as from the console, we're going to print this is running, right? I'm going to comment on main, and I just want you to see that if I run this, interpreter is not defined. 1 second. Where is interpreter? Okay, so this is actually model. The convention is interpreter, so we can actually change interpreter, model for interpreter, so it's easier. So we execute this and it says this is running. Okay, so if we go back, we're just going to continue writing our code, and we're going to execute main indeed instead of that print statement. So inside of this main function that we already have from that I pre-wrote looking at the Adafruit tutorial, we're instantiating a Pi camera with the resolution of the model input shape, right? We could parameterize this to be the model input shape, and we're going to do that right now. So let's actually return here so we don't execute the code below and see if that works. Okay, so what we're going to do is we're going to use this line. So we're going to get it from below. And we're going to define the input shape. And here, I'm just going to print the input shape just to make sure that we are doing right. Input shape is 1, 2 to 4, 2 to 4, 3. So input shape is what we need, where do we use the input shape here? Yeah, because the input shape really is for here, but in here, the input shape we want really is this one here. So it's 1 and 2. So let's actually just do this because otherwise it's too long. And we just put this here. And then here we can just use input shape. So what we do here is we're gonna define this way. So we actually get input shape and we're gonna print it. So we should get 224, 224, which is here is height and width. And here we're just gonna do input shape. So we define that via the model instead of via like hard coding that. All right, so we instantiate a Pi camera with the size or input shape of the model, right? So the same image size that the model wants, we're gonna capture that with the camera. So that way we don't grab images that are larger than what the model actually needs to predict. Then we do frame rate 30. We could change that later. Start camera preview. So this actually starts the camera preview and is displayed on the Pi TFT display. The camera warm up time. So we wait for 2 seconds. Maybe we can just print here a statement that says something like starting, and that way, you know, we just see that at the beginning, starting, and then we wait for 2 seconds. Okay. Okay, so we warm up and then we make a while true loop, which is basically an infinite loop that is going to continue seeking for the next frame. The camera is going to annotate text is going to be none. This is going to be the text that is going to be displayed on the display. Then we capture in JPEG format, and then we get that the image is going to be image open stream. And then here we have to set the tensor. We actually have to do the prediction right here. So let's go to the prediction code. We have this image and we need to see how to input that image into the model. So let's actually look at lobe basic prediction just to see how they were inputting that into the model. Because I believe the thing is lobe has this concept of an image model and it understands PIL images pretty well. So we don't really, let's say we don't understand PIL images that well, and we have to convert the PIL image into something that the model likes. So let's take a look at how to convert a PIL image into an input tensor batch that we can feed the model with. So image utils, crop center, update orientation, get image from file, process, preprocess image. So I guess here they're talking about a PIL image. All right, I think that PIL image loads by default. All right, so we can actually get this helper method in our code, or we could actually just do it. Let's write it. So we have a PIL image, and what we want is that our image is going to be MP. Do we have NumPy here? Import NumPy as MP. we import NumPy and then we do as array image and we divide by 255. And this is going to be, let's do the same thing that we did before. So we're going to be printing the min and max of the images that we capture, right? So we actually have these images captured there. And, if I put my hand, that should change. So let's see. Yeah, those numbers are changing, but we're remapping the image properly. And let's take a look at the shape of that image. This is actually waiting for a second because I added this here, but it really shouldn't. All right, so we have the right image size and the right values. Okay, so we convert to a batch tensor. We can add more comments of what we're doing here. Okay, so remap. To 0 0.0, 1.1, and then we convert to batch tensor. So this is going to be input batch. Let's look at our notebook. These they do a bit differently. They do it with NumPy. Okay, so let's do here run all. Okay, so we convert to image D type here with TensorFlow. We don't have TensorFlow in there in that runtime because we just have NumPy. So we're going to actually do what they're doing. That is going to be expand them. So we're going to get the image and then the axis is going to be 0. And then as so we'll do as type mpflow32, and that is going to be our image, right? So if we print the image shape now, I'm pretty sure we're going to get NumPy expand thems. Expand thems. Oh, okay. Typo. All right. So we get here this batch, and this is what we wanted. And you can see in here that we're going to be able to grab not just one image per second, but many of them. Right? So we get a few images per second. I'm not sure how fast this is going to be. But we're doing that. So we do this conversion here, and now we have this image that is actually the input batch that we want. So we can go, we've replaced this process here of loading the image by, let's go through it. So instead of loading an image from file, we actually capture with the Pi camera. Instead of decoding the JPEG, we open that with PIL and then get the image data in the range of 0 to 255. We don't have to resize because the sensor is already capturing images on the desired size. We do divide by 255, and then we also convert to the D-type float and expanded them. So this is the input batch, right? I would say, my understanding is it would be cleaner to just cast to the proper type and then expand thems later. But effectively here is the same because we're not going to have a batch. We always want to predict frame by frame. So we're going to go now into the interpreter. So we're going to set the tensor. We're going to do all these steps. So we just copy paste. We have like a step-by-step process in yesterday's live stream 93. set the input tensor with the batched images. So we get the index of the input and we put the input batch, which in this case is going to be this image. So let's just put here input batch, and yeah, and we predict, we get the output data, and then we get the prediction. So we get this the logit vector, we get converted into probabilities, and then we get some text here. So this text here is going to be so let's put here like a label is going to be let's just do here NP max prediction. So for now we just have this label, which is a number, and we'll also print it here. So print the label and do that. So let's see what comes out. TF is not defined. Okay, so let's see how to apply softmax with NumPy. Is there a way? The thing is, I'm not sure if we actually get like a different class. Let's see if we go to the basic example, the basic prediction. Let's see if they do something with it. So confidence prediction, perf counter prediction. Get the prediction label. All right, so they do have a way to just return the result. We don't, but we can do some stuff to also load the prediction, frames per second as they're doing here. So let's see if we wait, do we get here E? Okay, let's try this softmax function. So let's just put the softmax function here. Compute value, softmax value for each sets of scores in X. Let's see if we get that in here. Blah blah blah. Softmax. All right, that's not predicting anything at all. Let's print the predictions. Print predictions. All right, so the output data seems okay. Let's just try this for now. Yeah, I wish I could pipe the image right now, the image of the Raspberry Pi to the model. Okay, so let me. Okay, I wanted to print the label here and I didn't. Okay, so we're getting different classes, and I'm not sure if those would be the same that on the softmax, but softmax. NumPy softmax. Let's try that. All right. Let's see. All right. So it seems we're now getting some probabilities. Bam, bam, bam. So let me label output, label prediction. Let's try to see if they are different. So output. Predictions. Okay, so we're gonna put here label predictions and see. Note that I have the Raspberry Pi in here, and that we are actually predicting from the camera, and I'll try to show in a bit. Okay, so the prediction seems to be the same from both sides, even if we don't do the softmax operation to get the probabilities. So for now, we can forego the excuse me. So we can leave these aside, and one thing that we don't have here is I'm gonna create it manually at the moment. So I'm gonna just do labels txt, and I'm going to paste the list of labels that we had. Oh, we actually have to get them maybe from here. Let's see if this is active. Model labels. Yeah, so I'm just going to paste this here. So we have the labels, and we just have to, let me grab this code. All right, let's just try this. And TFLite labels path is going to be labels txt read the model labels. All right, so we just need to do here label is going to be, so this is label index, and then we'll say the label is labels label index, and then we just put here the label. All right, let's try once more. No such file. All right, that was bad. All right, so we just put here this and run. Okay, and now monitor. All right, lighter. umbrella, mouse, digital clock, iPod. Laptop. All right, so it's classifying properly. Nice. Great. Okay, so read lines. I wonder. Let's see if now we don't get those weird spaces. Okay, great. Microphone. All right, so it's actually recognizing pretty well. I'm now trying to figure out how to show you what's actually going on, and I'm just gonna add some more code here. So we're gonna add the label to the annotation text. Let's see if that works. So the label was showing before. Let's take a look at the code here. Wait for 1 second so the label is visible on the screen. Right, let's try it. Let's see, so if we don't wait, maybe we don't need to do this. Let's try this again. Nice. So this is actually showing on it's actually showing on the screen. Okay, so we have this working. It would be good to also get the data for the frame. So what they have here is the start performance counter. All right, so let's do one thing. Let's put this code here behind me, or yeah, so let's put this code here and put this one here. And let's add things with comments so it's easier to understand later what's going on. Start performance counter. So we'll add this here and capture a single image as a peel image. I like that one. So we're grouping. So this is classify, capture and classify. So classify images with TFLite, classify images captured by the Pi camera. All right, and then we'll put here based on low AI's script. Okay, and this is done by me. Okay, that's some credits there. All right. Great. So great. So we are pasting some code from here. So start prediction performance timer. So we're actually okay, and and prediction performance timer. So we probably want this to be in here. Get the prediction label. All right, so maybe we can move this above here. Add text to camera preview. And then print performance times. All right, so we're going to put that there. Calculate prediction time. All right, so this is just for performance. Okay, can we run this now? So label. All right, and I'm not gonna do this waiting. So we're gonna reset, we're gonna restart there. And let's see what's happening. Confidence is not defined. All right, so we actually don't have the confidence yet because we don't have the thing with the softmax, but well, actually we do have it. So we have it if we confidence. Okay. All right, so we were confident. So here we have the label index already. So we just have to get predictions and the index. So let's see if that works. Out of bounds for axis Z with size 1. All right. Frames per second, 2 frames per second, prediction frame per second. And what is this? 0.36. Okay, so we're getting something here. So we're getting a prediction. And now I guess you need to see this thing working. So I'm going to try to show it to you. So all right, let me see. how do we do this? So let's see a demo of the prototype actually working finally. And I have this thing here. Okay. So we have the camera, and I have to leave it so you can read it. Okay. So I'm not sure you're going to be able to see much of what this is really doing. It seems that there is a lot of green stuff reflected. Okay. Let's switch off the green screen. Okay. Lampshade. So I guess if we get there, computer, laptop, notebook, modem, computer keyboard. I think it classified this as a microphone properly, so that's pretty good. Well, yeah, the model is not great. What does it classify me as? What about the camera? Polaroid camera. Whew. Well, okay. So this is more or less working. I'm sure that there are use cases that are better than this one. And one of the things to note in this example, let me flip back the cameras. It was. Yeah, so one of the things to note with this example is that first, it's working. So it's running on the Raspberry Pi. Now we can start that project, so that Python process, and get a TensorFlow Lite working. We have used a pre-trained model from TensorFlow Hub. So note that we just downloaded that, executed a script, and with the Raspberry Pi setup, everything works. So that's pretty good. So the thing now is to actually create a data set where we train with images from, probably we need images, real images from this camera, and create a data set with Lobe AI, and then train it and export it to TensorFlow Lite. That would probably be super accurate compared to what we have right now, because it will learn from our environment and from these cameras quality and all that stuff. And yeah, so that's what we would want to be doing, not like just getting this model and try to use it for things that it hasn't been trained to. All right, so if we go back, I mean, you can see, let me see if I can if I can stop this. One thing, I mean, it's cool that we could do the SSH on the on this. Let's see, can we make this? All right. This doesn't flash properly. Well, that doesn't seem like it works. So we're just going to leave it as it is. We'll make this big. And what you can see, I broke something. Okay, so yeah, the long story short, we have this working. It tells us the confidence of whatever label it's classifying. So if I put it to the computer, like notebook or keyboard or something, we could use that for something. Like if it detects something with like a high, like lens cap is being recognized pretty well, for example, then we could do something if the percentage of confidence is high for some decent amount of time, right? Like maybe switch something on, or like play a sound, or create an action or something. I'm happy that we got here. So we've looked at how to run this thing with the Raspberry Pi, and it's working. As I said, this is a pre-trained model, and now we need to go to the next step, that is train our own models and see what we do with it. I want to thank you for watching. I'll remind you that you can like this video if you want to support the work that I'm doing here, and that you should subscribe and click on the bell if you're going to get notified when I go live next or when I upload new videos. We have new episodes released on the Getting Simple podcast, in case that you want to take a look. The latest with Zach Krohn on art, creativity, and personal evolution, and new episodes that will be coming and are in the making with Alex O'Connor on machine learning and the latest developments of AI, with Ian Keo from Dynamo and Hyper right now, Hyper AC, and also with Andy Payne and John Pearson. So stay tuned. I will see you really soon. Again, as always, it was Nono Martinez Alonso here. I create videos on creative machine learning and podcasts on creativity, technology, and culture at gettingsimple.com. Thanks for being there. Thanks for watching. And hopefully, I'll see you next time. Bye.